Okay, now look at this question. Here we have an infinite wire of linear charge density lambda. That is, charge per unit length is lambda. Here we have a charged particle, okay, hanging from a string. Okay, the length of the string is L. The particle has charge Q naught, mass M. Okay, this hinge is 2L distance away from the wire. So the particle is given a velocity v, and find minimum v so that the string becomes horizontal. Okay, so the string should become horizontal, right? Now one thing we can understand is that gravity will be acting downwards, and this wire is repelling this charge over here. Okay, the wire is repelling the charge, so the charge q has to rise against gravitational force as well as against the repulsion from this infinite wire. Okay, so we can solve using work done by the electric field and gravitational force. Okay, so initially the charge has velocity v, and when it reaches this horizontal position its velocity becomes 0. So I can write down over here that at this position the velocity becomes 0. Okay, right, v1, let's call it v1, v1 becomes 0, right? So while going from this point to this point, what is the work done by gravity? Work done by gravity will be minus mgl, because the height difference between these 2 points is L. Now what about the work done by electrostatic force? So for that, first of all, we need to write the electric field over here. So the electric field created by the infinite wire will be 2k lambda, oopsie, 2k lambda by r, where r is the distance from the wire. So k is 1 by 4 pi epsilon naught. So this will be equal to lambda by 2 pi epsilon naught r. Okay. So the work done by the electric field, will be integration q naught e dr. Okay. Q naught e is the force acting on the charge. So force multiplied by displacement, q naught e dr. Right. And if we replace this, okay, this will be q naught by 2 pi epsilon naught lambda integration dr by r. Now what should be the limits of integration? Okay, so we are going from distance, initial distance is 3l and final distance is what, 2l. So we are going from 3l to 2l. Okay, so this will be equal to q naught lambda by 2 pi epsilon naught natural logarithm of 2l by 3l. Okay, so l will get cancelled out, we get 2l 2 by 3. Okay, but since log 2 by 3 will be negative, so we could replace this with q naught by lambda 2 pi epsilon naught, and we have a minus sign over here, log 1.5. This keeps the things simplified. Now that's it. Total work done by system, we apply the work energy theorem. Work done equal to change in kinetic energy, right? So work done by gravity plus work done by electric force should be equal to final kinetic energy 0 minus initial kinetic energy mv square by 2. So work done by gravity is minus mgl. So minus mgl work done by electric field minus q naught lambda by 2 pi epsilon naught logarithm 1.5 is equal to minus mv square by 2. That's it. So v will be square root of 2gl plus q naught lambda by pi epsilon naught m times natural logarithm of 1.5. Okay.